Our topic for today is norm-referenced versus criterion-referenced tests. There are 6 purposes of assessment. A screening test is used to assess a large number of children to identify those at risk for language disorder. In contrast, an evaluation is an intensive, focused assessment to determine if the child is eligible for intervention. An intervention assessment is used to gather information about how the child learns and for selecting intervention goals. Monitoring progress is comprised of ongoing assessments to monitor changes, progress, and update the needs of the child. Program evaluation is similar, except the assessments measure whether the intervention program is effective. For example, all children respond positively to the intervention, or only those with special characteristics. When administering a standardized test, it is important to follow the instructions exactly so that everyone who gives the test administers it in the same standard manner. These rules apply to both norm-referenced and criterion-referenced instruments. The test taker should have the same opportunity to obtain their maximum score on the test. The test administrator must follow standard instructions for the test administration and items. Standard test materials must be used. Standard rules for counting items as correct must be followed, as well as standard scoring procedures. Standard test conditions should include a quiet, non-distracting environment and rules for breaks. It is important that the administrator provides no prompts or reactions to the child's responses. If you say good or that's right when the child answers correctly, but nothing when the child answers incorrectly, the child quickly catches on and becomes anxious. Use neutral encouragement, such as, "Oh, you're working so hard," or "You are doing a great job," periodically after both correct and incorrect answers. The test characteristics must be reliable and valid, or the instrument has no value, especially for identifying a child as having a disability. Reliability is the consistency at which test measures a target skill. In other words, if you repeated the test, would the child get the same score? If there is too much random error in the test or in the administration, the scores will not be reliable. The test manufacturer tightly controls the materials, instructions to the child, scoring procedures, testing conditions, etc., to eliminate as much random error as possible. To determine the reliability of their instrument, manufacturers run test-retest studies to see if their scores are similar. If the test has a form A and a B, the alternative forms are administered to the same child to see if the scores are similar. Finally, they may split the test in half, administering odd items on one version and even items on the second, and once again look for similar scores. A test might give you very reliable scores, but be invalid. Validity is the extent to which a test measures what it purports to measure. If it is a test of vocabulary, then there should not be items assessing grammar on the test. Manufacturers determine this using content validity, where experts evaluate the items for appropriateness. Criterion validity is established by comparing the scores received on the test to a well-established test measuring a similar construct. Construct validity occurs when a research study is conducted to see if the test predicts outcomes as expected. If matched groups of kids are split into a 6-week vocabulary program versus a 6-week math program, the scores on the test should improve more in the vocabulary group. This is a typical cover sheet for a test scoring form. Fill in the child's name, gender, and grade. Then record the child's school, examiner, and examiner's title, such as graduate student. Next, calculate the child's chronological age, as shown on the next slide. The form provides a list of subtests assessed. You record the raw score or the number of points the child scored. This is an unconverted score and tells you nothing. To be useful, the table of norms provided by the manual must be used to convert the raw score to a standard score. The age or grade equivalent provides an estimate of the level of the child, the level at which the child is performing, but it cannot be used to determine if a child has a disability. It is not a valid score for that purpose. However, it can be useful in helping you to plan the goals and activities that may be appropriate for intervention. In the case of a written language test, it can help you select a book at the correct readability level. The percentile rank is based on the normal curve, but is not valid for determining if the child has a disability because the intervals between percentile levels are not equal. The scale score is valid for determining if a child has a disability because the intervals have been statistically manipulated to have equal intervals, so a gain of 1 means the same thing from the lowest to the highest scores. The standard error of measurement tells you how accurate the score may be based on the statistical error in test administration. So a scaled score on this test may be plus or minus 1 of the score recorded from the table. Scores need to translate to something understandable, so the score converts to a descriptive term ranging from very poor to very superior. These descriptive terms are shown on the table at the bottom of the form in the blue square. Finally, tests that have many subtests can be combined into composites. The lines show which subtests can be combined. For example, only subtest 6 is used for the listening composite, but subtests 1, 3, and 5 are combined for the grammar composite, and all 6 subtests are included in the spoken language composite. The converted scores for these are found in the manual. To begin administering the test, the first step is the calculation. To begin administering the test, the first step is to calculate the child's chronological age, abbreviated CA. First, enter the date of the test To begin administering the test, the first step is to calculate the child's chronological age, abbreviated CA. First, enter the date the test is given in the order of year, month, and day. Next, do the same for the child's birth date. Begin with the day column and subtract. If the number of the child's birth date is higher than the current day, you must borrow from the months column. Remember to subtract the month you are borrowing from today's date. A typical month has 30 days, so you are borrowing 30 days. And to today's date to get the total. In this case, 33 days. Subtract the birthday from the converted date to get the day age, in this case, 26 days. Now subtract the birth date month from the remaining months for today's date, in this case, 7 months. If the number of the child's birth date is higher than the current month, you must borrow from the years column. Remember to subtract the year you are borrowing from today's year. Add the 12 months to the remaining months to get a total. In this case, 19 months. Subtract to find the month in the child's chronological age, or in this case, 8 months. Next, subtract the birth date year from the remaining years for today's date, in this case, 9 years. The manual will tell you what rule to use for rounding up. This is important because it determines what age to use in the table of norms. Once you have determined the age, enter it on the cover sheet of the test. Write the chronological age using a semicolon rather than a period because this is not a decimal number. If the manual tells you to round up, it's 9.9 years. If not, it is 9.8 years. The second step is to choose the correct entry point for the test. On a norm reference test, the items are arranged from the easiest to the most difficult. Many tests assess children across a wide age range, such as 5 to 12 years. You want to begin testing with an age-appropriate item, or about a year below the child's chronological age. This is presented in the manual and also designated on the test form. From this starting point, you must establish a basal and a ceiling to determine how many points to award the child or the raw score. The third step is to establish basals and ceilings. The goal in testing is to capture the most complete view of the child's abilities. The basal and ceiling allow you to obtain as much information as you can without tiring or frustrating the examinee by administering too many items that are either too easy or too difficult for him or her. Correct calculations of basals, or the bottom item that needs to be administered, and ceilings, or the top item where you can stop, is necessary to produce a valid score. Procedure can vary slightly, so use the rules in the manual. A basal can be reached at any item, such as 10, but if the child responds incorrectly, you may need to administer all the way down to item 1. In your report, do not report a basal was not reached. The absence of a basal has no effect on the score. Finding the basal should be done following the procedure in the manual. The basal is the point in the test at which the child is answering all test items correctly. Since the items are ordered from easy to hard, it is likely that the items below the basal would be answered correctly and do not need to be administered. To find the basal, start testing at the item suggested for the child's age or grade. The majority of tests have the same basal or 3 consecutive correct responses, but check with the manual to find the basal for that test. If the basal is not achieved, test backwards to a lower level item and continue until the basal is found or the first item of the test is administered. This final point is important because an error completely invalidates the test norms. All items below the basal are assumed to be correct and given their point value, even though these items were never actually given. Many test manuals direct you to find the ceiling before finding a basal. The ceiling is the point at which the child is missing all items and there is no purpose in continuing. From the entry point, continue presenting items until a ceiling is reached. A true basal may be found during this process. Therefore, a ceiling is often achieved before continuing the test to find a basal. The majority of tests have the same ceiling, 5 consecutive incorrect responses. Above this level, assume the child would miss the items if administered. In this example, we see 22 items on the test. According to the manual, the starting point for the child's age is item number 10. The child responds correctly to the first 2 items, but misses the third. So a basal has not been achieved. Continue testing to determine the ceiling and to watch for a true basal. The ceiling is reached at item 21, where 5 questions are missed. Item 22 was not administered because it is above the ceiling and therefore assumed would elicit an incorrect response. A true basal was not reached while finding the ceiling Therefore, return to the entry point and begin asking questions, starting one below the entry level. In this case, the item was responded to correctly, and thus the basal was reached. Subtract the errors from 21 to derive the raw score, which is 14. If you got a score of 6, it is because you didn't give credit to the 8 items below the basal that are assumed to be correct without administering them. The purpose of norm reference tests is to compare a student's performance against the performance of their peers. Normative tables show where a particular score is located along the normal curve based on the test taker's scores who made up the normative sample when the test was developed. This sample should be representative of the person to whom you are administering the test. The norms of a standardized test must be representative of those taking the test. Norms must provide all test takers the opportunity to score well. To do this, the norms must be representative of all of the people taking the test. This means people like you must be proportionally included within the sample of test takers used to establish the norms, that is, the normative population. The census is used by test developers to determine the proportion of the population that should be included according to gender, the proportion of males to females, region of the country, all areas must be represented proportionally to the density of the population. Urban versus rural, test items must be non-biased for city versus rural. Socioeconomic level, items must be non-biased for types of experience and opportunities for learning. Ethnic racial groups must be proportionally represented and non-biased for culture, language, or dialect. Culture, language, and dialect bias. Even if the distribution of the normative sample matches the census, there still may be cultural, language, and dialect bias. Different cultures have varying customs regarding roles, such as girls should be passive, beliefs and pragmatics, such as no eye contact with elders, and so forth. You have an obligation to know these unique cultural features to avoid scoring errors that are really cultural differences. Children who live in poverty may not have the experiences expected to respond to test items. Many children have never been to a restaurant, visited a museum, have the internet, or left their own neighborhood. Children who speak English as a second language may be identified as having a disability based on a test designed for native English language speakers. Children who speak a non-standard dialect of English that differs in many elements of syntax, morphology, phonology, semantics, narratives, or discourse may be inappropriately judged by a test designed for mainstream dialect speakers. What can be done to reduce test bias? You should have increased knowledge and awareness of cultural and linguistic backgrounds. Determine the level of acculturation into the dominant culture. This can be done by understanding the educational level of the parents, current status of employment, the number of children in the family, and income level. Controlling cultural variables. The test taker may need more time, may have different beliefs about testing, and there may be pragmatic issues. Determining language or languages used in the testing. You must test the child in the child's primary language for the identification of a disability. Also, don't score errors that are actually dialect differences. Ideally, develop local norms. You should also use well-trained interpreters who know the language and the community. Back up your test results with observations of the child's language use in functional contexts. A scaled score is a different method for dividing the normal curve. The statistical calculations set the average score as 10 rather than 100. It has 6 rather than 8 divisions with equal intervals between them. The standard deviation between each division is 3 rather than 15. Scale scores are often used to measure the performance on subtests, while index scores are applied to the composite or total test scores. This view of the normal curve shows the predicted performance level associated with scores along the normal curve. 68% of test takers will show skills or abilities with average difficulty. 14% will have less difficulty than average, and 14% will have more. 2% will definitely have less difficulty, and 2% significantly more difficulty. This is another view of the 1.5 standard deviations below the mean that is typically used to designate a disability. Note that at positive 1.5 standard deviations, the individual may be designated gifted. Age or grade equivalent scores are very different from index or scaled scores. They are based on an ordinal scale rather than an equal interval scale. This means after the normative group raw scores are lined up, they are not subjected to mathematical calculations, but rather left in the original form. This means the intervals are not spaced equally so that no reliable or valid comparisons can be made. This seriously limits the reliability and validity of the scores. Ordinal scale scores are based on the median or middle score rather than the mean or average score. Since there is no mean or equal intervals, there can be no standard deviation between age or grade increments. When the norms are established, all the normative subjects, regardless of age, are in an aggregate group, not just those in the age group, like interval-based norms. When the norms are established, all of the normative subjects, regardless of age, are in an aggregate group, not just those in an age group like interval-based norms. Because of this, the mean score for each age, 7 years, 0 months, 7 years, 1 month, etc., is calculated. So sometimes the mean, for example, of the 7-year age equivalent would be higher than the 7.4 age equivalent. The age or grade equivalent is a frame of reference for growth typically expected with increasing age or grade rather than performance compared to peers. Because of the many limitations, these scores cannot alone be used for any interpretation or decision-making purpose. In summary, the reference group for equivalent scores are across different ages or grades. For a standard score, they would be within an age or grade. The equivalents are a measure of growth, while the standard scores are a measure of performance. The equivalents are based on an average or median score, whereas the standard score is based on individual scores. This is a more elaborate explanation of the reliability and validity problems with age and grade scores. The reliability of age and grade equivalent scores is limited by the relationship between the equivalents and the raw scores. First, an age or grade equivalent is the median raw score for a particular age or grade level. Developmental changes occur more rapidly during the early ages, and so a raw score increases at a greater rate. This means that a similar change in raw scores, like 5 points, will show a bigger age gain for younger children than the same 5 points for older students. Another problem is that if a score isn't reliable, meaning you can get a different outcome each time you test, it can't be valid. All of this means that equal interval standard scores are a more accurate representation of the examinee's abilities because they are based not only on the mean at a given age level, but also on the distribution of scores. However, age and grade equivalencies are useful for selecting instructional materials at an appropriate level. They cannot be used, however, to identify a child as having a disability. One of the most popular scores reported is the percentile score. It has 99 intervals from below the first percentile to above the 99th. The problem is, it is an ordinal scale, and as you can clearly see, the intervals are not equal. Instead, the intervals between one score and the next are very wide at the outside edges of the curve, but overlapping in the center. The average score assigned as the 50th percentile on an ordinate scale is a median rather than a mean. The intervals are all different, so there is no standard deviation. All the problems discussed regarding age and grade equivalency scores are also true of percentile scores. However, percentile scores are very popular scores because everybody understands percentages. When you tell a parent their child has a scaled score of 3, it is meaningless without further explanation. When you tell parents their child scored in the 7th percentile, they have an immediate interpretation. So, can't the percentile score be converted to an equal interval scale? The answer is yes, and it is called the normal curve equivalent. Like the percentile score, it has 99 intervals, but this time the average is the mean score, and each interval is equal. Compare the distribution of the intervals between the normal curve equivalencies in red versus the percentile equivalencies. The 10-unit increments are equal across the normal curve for normal curve equivalencies, but vary widely for percentile increments. A percentile change of 10 would represent very different amounts of change depending on where the normal curve the change is occurring. Statistically, the normal curve can be manipulated to derive a wide range of scores with different assigned means and standard deviations. However, since they are all derived from the normal curve, a child's score should be in the same place under the curve regardless of the measure used. If you report several scores on the same subtest, such as an index, scale, and normal curve equivalency, they should not be in different locations under the normal curve. This is a red flag for anyone reading a report and suggests at least one of the scores is incorrect. Because of the difficulty interpreting equal interval scores when given the numbers, descriptive items have been assigned to intervals of test scores. In the table, a child who received a scaled score of 4 or 5 would be assigned a poor rating. This would include slightly fewer than 7% of all children that age. The same rating would be assigned to a quotient or index score of 70 to 79. Likewise, a scaled score of 8 to 12 would be described as average, with close to 50% of the population scoring in that range, as well as an index score from 90 to 110. Criterion-referenced tests are very different from norm-referenced in purpose, design, and outcomes. They are designed to measure whether test takers have mastered specific knowledge and skills. This includes projects and exams in classes, achievement tests such as the Peabody Individual Achievement Test, a test of physical fitness, or a reading inventory. People pass the test by reaching a criterion such as 70% mastery. Scores can be rated along a continuum such as mastery, approaching mastery, above or below mastery, or independent, instructional, or frustration levels. The Peabody Picture Vocabulary Test is an example of a norm reference test. It is designed to assess a wide age range from toddlers to adults. Items begin easy and get increasingly more difficult with only 1 or 2 items at any level. Basals and ceilings are designed to indicate where to begin and end testing. The raw score is converted to norms to estimate how well the person performs compared to peers. Never teach items from a norm reference test because gaining 1 or 2 vocabulary words makes the child appear to have changed dramatically in vocabulary ability, when in fact he or she only has learned 2 words. In contrast, the MacArthur-Bates Communication Developmental Inventory is a criterion-referenced test. It is designed to assess a very narrow age range with a good representation of items to test how well the child has mastered the skill. Thus, MacArthur tests 36 animals, 9 vehicles, and 30 food items known by preschoolers. The unknown vocabulary words can be used to develop lesson plans because learning age-appropriate words is the goal. The Gray Oral Reading Test is a norm reference test. The passages are not graded, but increase in readability from beginning to advanced levels. The raw score is converted to standard scores that indicate how well the child reads compared to peers. In contrast, the Basic Reading Inventory is a criterion reference test. It presents a continuum of reading passages from kindergarten to grade 12. Reading fluency and comprehension are separately compared to the criteria of independent, instructional, or frustration reading. The results indicate the level of materials that should be presented to the child for instruction. Tests that assess content areas include quizzes, projects, and exams that are often teacher-made criterion reference tests. They compare a person's performance to a set of objectives. Anyone who meets the criterion can get a high score and can attain mastery to meet them according to an A to F grading scale. It is possible for all of the test takers to achieve 100% mastery. Both norm-referenced and criterion-referenced assessment instruments serve a critical role in assessment. There is an almost limitless array of tests of both types. Learning when to use each type of test to meet needs and goals is a critical skill for SLPs and other professionals.